Okay, we're back. We're back with Ayush, who's going to talk about finding little secrets in code. Over to you, Ayush. Thank you.
Hey guys, so I'll be speaking about hunting secrets in code. Uh, I am Ayush. I am a DevSecOps engineer at a company called AppSeco, and I'm also the co-organizer for Winja CTF. So before we begin, there's some jargon that I'd probably use during the talk. So just to give you guys context, when I say secret is essentially a sensitive piece of information such as credentials, API tokens, something like that. Secrets management is the process of storing and using those secrets in your application code and like other places wherever, like such as automation. When I say scans specifically for this talk, I mean like scans to identify secrets in code. Compute is any service that you can like run code on essentially, and infrastructure is just a system of services, tools, whatever, to achieve a certain goal. Let's say deploy an application, scan for stuff, build your dependencies, so things like that. Yeah. So challenges in secret management. How do secrets get leaked in the first place? So like the way that we are progressing right now, people want to do automation, right, for everything that they can like get their hands on, uh, essentially to like say, let's say, improve the speed of delivery and other stuff. But to do that, we have to enable our code to perform actions on our behalf, and because of that particular reason, we add secrets to our code. Let's say you want your code to access your database, you need to give it the database credentials, right? That's perfectly fine giving your code credentials. That's not the issue. The issue arises when you start committing those secrets to your code, essentially with like a version control software such as Git. And Git never forgets, because it creates a history of like all the changes that have ever been made to a source control repository, right? And because of that, even if you in future commits, you, let's say, remove your credentials and like whatnot, I can always, like, if I have access to your source code, obviously I could go back to that particular commit and scan through all those changes that you've made and still figure out what those secrets were. And if you have not rotated them, then you're in a world of trouble. So why scan for secrets? I mean, the best part being that it's not something that people are not aware of. Like we all know that credentials get leaked every now and then, and scanning for them is extremely important, because I mean, hoping that they never get leaked is pretty much wishful thinking at this point. So this is a code that Google SRE motto, which is like used by Google SRE folks. I mean, this is for them to like maintain uptime and other things, but like I think this applies for a whole bunch of other things as well, such as like scanning for secrets. And why would you also scan for secrets? Because they provide you the backbone of authentication and authorization. So they allow you to like impersonate someone. So the point is that credentials that get leaked are meant to be legitimate, right? They're not fake credentials that were generated by a malicious actor. They were meant to be used in the right way by a developer or someone else. But the moment that they get leaked, I can use those credentials as a malicious actor, and then I can like impersonate that person essentially. And then it also allows me to access certain actions and operations, right? So it also reduces attribution. Attribution is itself like already a difficult problem in infosec, but like the fact that leaked credentials create this ambiguity between if it was the person who was intended to hold the credentials and the person who might have gotten access to these credentials to some or the other accident or something like that, which creates this ambiguity and essentially in essence issues for incident response. So what can happen if the secrets are leaked? The most obvious common thing is account takeovers. Let's say I get hold of someone's Twitter API token. I would try to post, let's say, on his or her behalf. If someone's SSH credentials get leaked, through part of this their deployment setup, let's say, so I can put in crypto mining tools and something like that that can like mine currency for me while you foot the bill for it. And there's obviously other kinds of monetary damage. If AWS credentials get leaked, I can launch expensive resources, make you pay the bill and everything like that. So available tools. So you obviously don't need to write a scanner for yourself, because this is a solved problem. This is not something new. People have solved this issue through two mechanisms essentially. One is like an entropy scan, and the other being a regex based signature scan. So entropy is essentially a measure of how random a certain string is. Let's say your password, like a typical good API token or a password or something like that, should be extremely random. And based on a threshold, you can tell these tools that, hey, you know what, if this secret is random enough, this string is random enough, let's call it a secret. And then it can identify those things based on those thresholds. The other thing is where you can define patterns. So a lot of secrets have a specific pattern. Let's say AWS credentials, like that you use for your CLI stuff, is always start with the 4 characters AKIA, and then they're followed by a 16 character alphanumeric. So you can create a pattern for that. Same goes for like your Google Auth tokens, which start with AIZA, and Slack tokens, and a whole bunch of other things. So you can create such patterns, and then based on these regex patterns, regular expression patterns, you can like uncover secrets hidden in code. And all of these tools do a really good job of scanning through the history as well. So you can ask them not to do that, but like the best part about them is that they scan through the entire history, so that even if there were secrets at some point in the code and not currently, it will still find you them. I personally have tried these out, but there are obviously many more. I prefer Git secrets and Trufflehawk. Git secrets because it's really extremely fast, and it integrates with the existing Git command as well. So once you've installed it, it becomes Git secrets, and then all the sub commands like scanning and other things. And Trufflehawk because it's extremely easy to install, use, as well as it has the like about 40 signatures already present in it. So you don't need to go craft your own signatures to like scan for secrets. Coming to proactive actions. So I mean, we know that we can scan for secrets. We know that code will have secrets. The point is, where do you scan for them, right? So do you need to run a scan every time you push your code, before you push your code to like GitHub or wherever your code is supposed to go? So do you need to? No, because as of right now, most modern companies, or like most companies, handle their code in certain ways where there are multiple checkpoints that all the application code passes through. This could be your automation server, such as say Jenkins, or we'll obviously have a place where all the code is stored, like GitHub or Bitbucket, or maybe a self-hosted GitLab server. So all of these places can be used to scan for secrets. So essentially, you don't need to like scan every time you push. And obviously, we can also have periodic scans. This could be a part of where your code is stored, and then a periodic scan is triggered every now and then to scan all the repositories and such. The issue with like periodic scans is that there's a time gap between the two scans, right? And if in between that gap someone pushed a code that had secrets and got deployed, it will trigger it will only uncover that the next time is the scan run. So it's not immediate. Whereas in integrated scans, you can run it every time, essentially during the build time, but the issue is that it will increase your delivery time. So it's kind of a trade-off. So coming to, should you scan every time you push your code? So I would suggest yes, but we'll get back to this in detail later. So do you need to pay for a new server or something to like essentially scan for secrets in your code? So no, again, GitHub Actions is something that GitHub released now a little while back. It's been a while. It's essentially a compute service where you can run something called workflows, which is a set of instructions that you can like give to GitHub Actions, and it'll run those instructions against your code in your repository or even other places. You can like do a whole bunch of things. It's as simple as writing a workflow, creating this directory, committing the workflow, and triggering the event. So this is a sample workflow wherein I will trigger this workflow on a push on the master branch or main, if you've been following the news recently. And I define a job called scan, which runs on Ubuntu 18.04. I check out, essentially like go to the repository, I install Python, I install the tool, and then I run the scan. And that's about it. And this will generate the results in the form of workflow and under the actions tab in your GitHub repository, and then you can do whatever you want to do with that. But what happens if you already have a setup? Let's say you already use Jenkins, or let's say Circle CI or something like that. In that case also, it's still doable. If you don't want to integrate, let's say, GitHub Actions in your pipeline, that's perfectly fine, because then you can just install the tool on your Jenkins server and add that as a build step or something. But if you do want to offload all of your tooling to a different server and like to avoid, let's say, dependency issues, you can use GitHub Actions. You can like code on your machine, send it to GitHub. Jenkins will pick up the code from GitHub and trigger a scan on GitHub Actions, because that is an event that you can trigger manually as well. Then it can fetch back the results, and then you can do whatever you want. If there are no secrets, then you can try. You can essentially deploy. If there are secrets, then you can block and alert on those secrets. So scanning obviously is one way, and we will be talking about scanning itself, but there are other places or other ways to mitigate stuff as well. So git hooks is essentially what I was kind of hinting towards earlier when I said, should you scan for before you push? So manually scanning secrets every time you add changes to your code is going to be a handful. I mean, like at some point you're going to get bored of it, right? and so will your developers. So the nice way to do it is add a git hook. So once it's configured, a git hook is essentially a set of commands or a command that can run on a certain specified event. So a pre-commit hook would be something that if someone commits changes, that command would run in our case a scan, and if there are secrets, it can just stop the commit from happening, and if there are no secrets, it commits as usual, no changes there. Similarly for pre-push, push rejection is on the other side of the spectrum, wherein let's say you have a GitHub Enterprise setup, or you have a self-hosted GitLab server. So whenever you receive a push, you can trigger a scan at that point, and that scan could then specify whether if the code has secrets, and then you can reject the push or accept the push based on that result. The best way is to use a secrets management process, again, in my opinion. There are tools to do this, and there are services to do this. Tools like HashiCorp Vault, services like AWS Secrets Manager. What these essentially do is give you a trusted space to store your secret, whatever they might be, and then they are fetched as and when required. So your code can have placeholders such as environment variables or .env files, whatever you want to call it. And whenever just the second last step essentially before you deploy your code, and when it will actually require those secrets to do its actions, that's when you fetch those secrets and bake them into your code in the form of whatever files or environment variables, whatever you want to do. And that segregates your secrets from your code up till the exact moment that it actually needs the secrets. So you obviously can't have it in the deployment state, post deployment. So you have to have it when you're just about to deploy your application code. So that's where you can use the secrets management process. This could be even more comprehensive in the way that you can add scripts and other things, but this essentially is like the base of it. One common thing that people do ask me at times is that why not use git hooks all the time, and why do you want to have a central scanning setup, right? So why scan in, let's say, Jenkins and not have a hook all the time? I would say that, the ideal way obviously would be to have git hooks so that every developer can never commit secrets themselves. But the issue is that, let's say that you want to add a new signature. Now that becomes a pain to add it for all the developers that are in your team. Whereas in central scanning, you add it in a single place, and then it just works for everything else, right? So git hooks essentially are a developer's discipline thing, and central scanning is easier for management and other stuff to maintain your signatures, results, and you can have a central place to monitor stuff and all sorts of other things. So that's why people generally, and even I would prefer central scanning. But yeah, if you can, and if you can implement this, git hooks definitely are a really nice touch to it, because then your secrets never end up in your code as well. So there's no need for rotating secrets, there's no need for monitoring for them, because they never end up in code, right? So yeah, that. So we've talked about secrets, and you might find that it's pretty much theoretical at this point. So I did create a repo for you guys, so whoever wants to can go to this particular repo. I've hidden a flag here. You won't find it obviously on the face of it, but if you run a particular scan, you should be able to find a particular funky looking file, and that should have a flag. And if you DM me the flag, I will send you some appreciation, because that's all I can send you. So yeah, feel free to check this repo out and use it if you want to. That's perfectly fine. There's one particular file that you need to look for. With that, I'd like to thank you guys for listening in. Thank you, Beer Farmers, for having me, all the mentors for your help. And if you guys have any questions, I'll take them now.
Okay, thank you very much, Ayush.
Thanks, Ed.
We don't appear to have any questions, certainly coming from the room.
Couple points.
Yeah,
I just think no one can make the argument that you don't know what you're talking about. That is very technical and very fast, my friend. Nicely done.
Thanks.
So overall, what are your impressions of sort of the code that you're seeing today and sort of the quality of it? Do you see improvements, or do you see the situation getting a lot worse?
It is kind of both in a way, because people are looking for automating as much as they can, so they are definitely pushing in more secrets in your code, but they also realize that it's sensitive pieces of information that they're pushing in, so they're more careful about it as well. And as all the news comes in, data breaches and whatnot happens, and at a lot of times these are very simple things that have happened, right, because of someone leaking their credentials, or maybe I don't know, for whatever reason. So they are more careful as well. So it's a bit of both. I'd say.
Okay.
Thank you. Awesome.
Great.
So
Super. Yeah, Sean.
I had a question because a lot of what you were talking about is something that my team actually tried to tackle years ago before anything was available. You're talking about probably the most available thing was just a commercial solution that cost thousands and thousands. So what kind of like, what's your advice for especially smaller teams? I know you mentioned something like Vault and that that is quite monolithic and big. Maybe some might see it too big for smaller projects. Do you know of anything that maybe is more applicable or more useful for smaller projects and smaller teams?
So if you are going with the secrets management process, there needs to be a central place. So in most cases it's Vault, but if you want to go the service route, there's obviously secrets manager, there's parameter store as well with AWS, and even at this point right now with GitHub, you also have the ability to add secrets to the repository as well as organization secrets themselves. So that does not really cost you anything. So you can add secrets there, and you could use something like GitHub Actions to invoke those secrets without ever having to worry about like where to maintain them and everything. So if you have like some central credentials such as SSH keys to deploy your code, that could be an organization level secret, so that all repositories under that organization have access to that. And if it's a repo specific secret, it could go there, and then it could also again be used under the GitHub Actions space.
Ah, fantastic answer. Awesome.
Super. So some great feedback. Awesome talk, cool talk, great talk. That's from the people that are watching online. So very well done, Ayush. Thank you very much for sharing your time with us. And we're done. Thank you.
Okay.